So we'll start from post, just 10 minutes later. So post 30, sorry, 3:30 the release time, but we'll start 3:40, right? The 3 minutes later, right? Or 2 minutes later, we will start, Yeah, still you can have your 10 minutes, but don't mind. So I think everyone was kind of saying, listening the opening ceremony, right? Yeah. So I was not really checking the time. Sorry for that. Yeah. Okay, it's 3:40. It's time to start. Thank you for joining us for this afternoon session number 2 for Cloud Working Group. So this time we have two presentations, a little bit shorter one than before. The first one has a very interesting title called the GPU Playground, implementing Kubernetes clusters for efficient GPU workload and portable shared environment. This will be delivered by these two gentlemen, Pat and Nat. So they belong to EGAT and also related to the no, belong to July local university. Please welcome them for their talk. Please.
Good afternoon, everyone. Yes, in this afternoon, we will start from the presentation. Yes, in this talk, we will talk about the implementation of our Kubernetes cluster. We call it as a GPU playground. Yeah, we starting from the 3 years ago that we got the budget to implement the IoT cluster platform. The objective is we try to create a playground to study as an academic way to study on the container technology. At that time, we would like to utilize the most benefit from our infrastructure. So we select the technology on the container orchestrator, like Kubernetes. Yes. At that step, we firstly implement the very simplest way that we deploy the master node and following by the worker node to running together as a container way. And inside the cluster, we have one NAS. Next infrastructure. We also would like to collaborate with many countries. Like we work together with Laos, Cambodia, and also we work with the NECTEC. Yeah, we send our access box that deploy with the worker node inside, and we build it all with the big one cluster. Like inside the Uninet, we deploy the Kubernetes master node for the 3 nodes to enable Kubernetes high availability. and then we separate the worker node to the many country, but all of those will be belong to the Jula, like installed in the Uninet at that time. Yeah. So last year we also went to South Korea in the Chit. Want to there we would like to research on the playground that we implement the Kubernetes cluster that try to enable the GPU inside. At that time, we want to enable the GPU in the way of the resource sharing together. How do we make the communication between the GPU hardware to be integrated seamlessly to the Kubernetes? Yes. And the way that we select Kubernetes, because that we also can collaborate, like we select the rancher platform that can visualize the whole infrastructure that able to collaborate to deploy the workload together. And after that, we also consider the system that how do we manage the storage system hardware together, like a one pod, like a one workload can utilize the storage among the many hardwares that try to integrate the hardware system together. So this is another layer of the storage. And lastly, it also had the issue about the federation. As you see that we collaborate with the South Korea, we collaborate with the Cambodia, in the Malaysia. We try to develop the interface that able to communicate among the Kubernetes cluster to study on the way that we can federate the resource across the cluster also. As you see that as a DevOps way, there are so many components that we need to train, to develop, to experiment. And after I went back to my company at the EGAT, the hardware is, the challenge is that how do I implement as a traditional way? At that time, we have about 1,000 virtual machines running inside the company. Then how do I can initiate the project on the DevOps platform? Like we would like to increase the maintainability. Like a 1,000 VM is not so manageable. Like from the old colleague that already retired. It's like we still don't know what is running inside. But if we develop like the Kubernetes way, like we containerize it, it is provide ability to manage the workload, and also DevOps can be provide a more optimized way to utilize the resource also. So like this, I'm studying with my professor, showed it before. He mostly provide me the focus on the repeatability. Like I try to focus that how do I can build the system that repeatable. Like I would like to make sure to deploy those Kubernetes cluster, deploy those storage layer, and also those GPU playground, like the mechanism that we can integrate the GPU driver into the big one cluster. So in this picture, you will see that all of these components this is an open source. Yeah. So it's like we would like to build a big playground to let our student in Chulalongkorn that be able to study on the container and also can deploy the workload that utilize the NVIDIA, the hardware easily and be able to share across the many projects. So at that time in the Chit and also nowadays in ECAT in my company, I developed the step to deploy the Kubernetes that's able to enable the GPU system by this component. The important component is that you have to install the NVIDIA GPU driver for sure. The secret is that for the NVIDIA Docker tool and the NVIDIA device plugin, there is some tricky step that you have to make sure. Okay, I will start from the NVIDIA Docker tool. For the NVIDIA Docker tool, the way that you can start that, the package is not so that automatically itself include in the Linux. Firstly, you have to update your packet repository list by direct connect to the NVIDIA, and then you start manually update, and that time you will be able to install the NVIDIA Docker. After that, you can try test by the running the very simplest image, which is the NVIDIA CUDA, to check the ability that your Docker already being connected to the GPU. Yeah, and then that's it. Now your Docker engine will be able to connect to the NVIDIA already. Next is to try to install the NVIDIA device plugin. The magic that how the overall Kubernetes platform will be able to connect to the NVIDIA Docker and also connect to the Docker engine. Because of the big one cluster will be includes many nodes, like a simple node without GPU, and some node has GPU. If you deploy this by default, it will be not so good. So you have to customize your configuration that to intentionally to run inside the node that has GPU only. Yeah. So that is the idea. So all of it, you will see that now the cluster will be able to utilize the GPU and also manageable from the Rancher platform also. So yes, from the point of view that in the morning that actually for the Kubernetes itself, it has ability like a queuing, a task, like we are able to run the container and also the cron job workload. Like from this way, we also able to provide a mechanism that any workload that we want to make it to be run the scheduling, yeah, it will be possible for the for in the Kubernetes cluster. So it's like when I go back to the EGAT and I have start from the small cluster with I have about 10 projects that deploy with the containerized process and deploy in this cluster. In the EGAT, we deploy for the 9 node of the Kubernetes, and 2 node has the NVIDIA GPU inside. That they don't need have to understand how do we implement all of these stack, but they will understand just only that if they can containerize like just provide a very base container from the CUDA, it will be able to run the GPU workload for the from on this platform. Yes, and I just let them focus on the coding on the application only. No need to concern about the operation on the infrastructure. And because it is a very like a first time of the transformation of the as a container way. So I don't want to invest a big money on the buying on the building a big cluster or the GPU technology. But when we have much more the workload that running inside the Kubernetes, and also we really need the GPU power, we may decide the Kubernetes has to expand more or take the decision to deploy on the public cloud for some for some time that we need a processing power at that way. Yes. So that is the idea. Yeah. So and if we can decide good enough, yeah, GPU will help a lot. Like it's better than from the CPU task in the same task. Like a GPU is good on the parallel thing, something like that. Yes, that's all I have. Yeah, thank you.
So currently, who are the users of your system?
I have a developer team in the EGAT because it's a big company, has about 20,000 employees, and we have about 200 programmers. Yeah.
Okay, so currently it's open for certain company to use it.
Yeah, only in my company do you say?
So this is a company project. It's not a university project.
Actually, from nowadays, I still as sometime I went back to the university also. Yes, I do both. Yeah. Inside the university has a machine to do on the academic, and also my main job is work for the EGAT, electricity generation for Thailand. Yeah.
So you mentioned this software Rancher.
Yes.
Can you explain what it is?
Sure. Because the way that we need some time to study how to use the Kubernetes like this. Actually, Kubernetes doesn't provide a visualization on the container management. The rancher will deploy one workload that try to visualize all of these things in the big picture.
Okay, so this is just a visualization tool.
Right.
Okay.
It helps us to manage the container.
So I have a question on your architecture. In the previous slide, you mentioned that there are 3 master nodes. Yeah, 3 master nodes, right?
Yes.
So typically, I can see a typical Kubernetes cluster has probably a single master that contains the API server, etcd,
Yes.
persistent. So here, this means you have 3 replicates of the same server, or you have 3 servers to serve as the master, or it's a different kind of concept here?
Thank you. Actually, inside one master is include two things. One, the control plane, and other is a database. Yeah. For the master, for the three master, it also has a control plane and a master node for all. It's like it's working like a cluster. It's like if one of them down, the other will try to find the leader, both.
So,
Yeah.
so these three masters, they are identical?
Right.
Okay,
But working once,
redundancies.
redundancy.
So this whole redundancy is implemented by yourself, or it's part of the Kubernetes functionalities.
I utilize the Kubernetes mechanism.
Okay, so they do have these resilience kind of.
Right.
I see. It's recommended. I see. I see. Yeah. Okay. In the next slide. Next. Yeah, so I'm trying to understand the previous one.
Yes.
Yeah, so here, what is an engine? And
Yes.
yeah, so can you explain a little bit more?
This image is another issue of the storage.
Sorry.
Yeah, storage. The way that we have many nodes, this one is the physical. Is the physical analogy. Above is like a logical. For each workload inside the Kubernetes, we call it as a pod. For the pod itself, it has their own IP address. The main idea is that for each pod that we don't care that running from the whatever node, is that the engine is like the storage engine. It's like the mechanism that this pod can utilize the physical node storage across nodes.
So, okay, so you're building a common storage layer for the upper containers.
No,
No?
I combine. Yeah, I didn't implement this mechanism by myself. I install it. It's like the concept that I would like to implement the Kubernetes playground include the storage mechanism. This picture, I enable this picture inside the playground also. It's like I just combine the software-defined storage.
So
Yeah.
this engine is also a component of Kubernetes itself?
Not
No?
no.
So then what is it?
It is another software. We call it as a Longhorn. It's
Oh,
yeah. It is another component.
so
Yeah.
this is an open source.
Also,
Okay, so it's a Longhorn engine.
right.
So you can leverage that to build
Storage.
a storage layer.
Right.
Okay, okay, I can see that. Yeah, that's why that's my question. I'm not familiar with Longhorn Rancher, so
Yes.
I know this is a Prometheus that logo,
Grafana.
Grafana that's for visualization, but I don't know the others.
Yes.
Okay.
It's like a management workload that we needed to manage the whole cluster.
Okay, so Longhorn is the solution for
Storage.
persistency, for data persistency.
Right. Also,
Okay, okay. Otherwise, you you have to do
Manage,
your
right.
maintain by yourself, right?
Right.
Like make sure that the volume or whatever
Exactly.
customer resources.
Yes.
Okay.
For the traditional way, if we deploy only Kubernetes, for each workload that would like to utilize the hardware like the storage, we have to set it to map the storage directly to the to the physical node. So it is not possible to migrate one workload to run others and try to utilize that storage.
Okay.
Yeah.
So for your applications,
Yes.
do you have the cases where you have distributed applications, meaning one application might need multiple containers, and these components inside a component containers need to communicate with each other and having like dependencies on each other. Do you have those cases?
Yes, we separate the application to be two types. One is stateless and one is stateful.
Yeah.
For the stateless, we don't care because we don't need to map the storage to make it persist from the storage. But for the stateful application, yes, we have to decide that, okay, for the app that is stateful, that would like to deploy in the cluster, we enable the storage to be able to utilize the storage across the node.
So you mean for stateful applications, primarily you use the storage layer for them to communicate with each other. Is that right?
Um,
So this is one way, but I mean,
Yeah.
whether you have like direct communication, can they talk to each other?
Yes. Yeah. For the workload communication, yes, it's inside the Kubernetes, they has a way to isolate the workload. It's like you would like to separate the environment that we want to let these workload that communicate each other. You can do it directly, and also we can.
So you may use namespaces.
Exactly.
And then just
Yeah.
let the containers know each other's maybe virtual IP so that they can
Right.
communicate. Is that the way you
Yeah,
said?
this is the way that what the Kubernetes do. Yeah. Right.
Okay. So have you thought about maybe messaging queue kind of services
Possible.
integrated with Kubernetes?
Sure. The workload is just like it's just a workload. So you can deploy the message queue mechanism. You can deploy web server. You can deploy the database. Anything, any workload.
Okay. Thanks. Because I think the design space is quite wide.
Yeah.
You could also consider cloud native patterns like sidecars for them to communicate like through certain kind of services. But yeah, I'm also learning myself, trying to understand the similarities, differences, pros and cons. Yeah. Thanks.
So if I add some comments, so basically, basic mechanism containers, they can talk to each other. So some containers say standardized interface for CNI, container networking interface. They are in charge of those communication among containers. Okay, the message queue can be some application which is containerized by itself. It's application thing. Okay, you can adopt any kind of messaging queue applications containerized, then they can be part of this thing. It's on top of this thing. Okay, another aspect is for something for the CSI. Long one here is kind of linked to the rancher, but anyway, it's take care of a CS storage. They can add on thing, making storage thing more easy to manage. But anyway, the fundamentally goes down to CSI container storage interface, which allows all these containers kind of talk to how they are talking to storage. It's another thing. So basically, you have to think about the CNI, CSI things as a basic thing in the container level. Then on top of those, there's a higher level thing. Also subsmesh, which users call the sidecar, linkerd, is still all the subsmesh thing is some made higher, so the compatibility of so container application, how they need to talk to it in a more operation specific way, which allows the kind of developers to do their own programming without knowing actual infrastructure. So they give a different level of isolation, leveraging namespace to technology and so on. Yes, so probably you are filling up those space, but so there are several more things, but there's if you go further, there's something more. Yeah, it's not really simplified, but it's becoming really very much organized and very much diversified.
Yeah. I could imagine there are not only one solution, but
yes.
but at different layers also, right? I mean, CNI, CSL, are there the more fundamental
thing, yeah.
container, and based on these, I think there's also cloud native open source solutions nowadays, I guess, build upon those things, and really depends on maybe the need and demand from the applications.
So I do recommend it going down to the basic things, also going up to a more convenience level tools. You have to understand both things. But both this basic things is fundamental, right?
Yeah.
And then other convenience tools are built on top of those. Right. Okay. I think time to thank our speaker. Yeah, thank you. Then we'll move on to our second talk. Yeah. Mark. So I need to check title of talk. Should be ready, right, soon? Okay. You are going to, do we have a remote participant? Someone is joining us from remote or yes or no? Yes, so someone is there. Yes, right now. Then we, yeah. All 6 participants are there, so we have to use this one. Yeah, yeah. Yeah. So you keep the information. We have a Zoom, so he can join the Zoom by himself. Okay, you're joining. Okay, good. Okay, while he's preparing his Zoom link to be connected. So, so a lot of you may have interest in knowing Kubernetes, right? It's really gaining momentum. Actually, I'm kind of annually attending Kubernetes conference held in Europe. So the attendance is increasing. Last year, 1 year ago, yeah, they recorded more than 10,000 attended. So open source, yeah, kind of meeting, attracting more than 10,000 participants is a record number. So you know the Linux and all those things, they didn't get that number so far. But Kubernetes, it's part of a Linux Foundation, which is called the CNCF, Cloud Native Computing Foundation. They was able to attract more than 10,000 people on site. And so that's kind of momentum they have. So probably you will see a lot of cloud things, which probably based on this Kubernetes cloud native manner. So that will be free from login and so on. So it's quite promising, and knowing the details, it's really interesting. It's evolving, it's improving. Improving, which means it's getting a little more complicated before, right? So now ready? Okay. Now, please welcome our second speaker. Yeah. So, there. Your screen sharing and your screen is too small. Mhm. This it is going on. Not yet. Okay. First, the good thing is we have this after we have a time to have some kind of discussion, so we can wait for them to. Anyone who have some kind of questions in general about cloud working group, I can spend time while they are preparing. Yeah. Okay.
So I was at the network engineering workshop, so I missed the morning session. So I'm curious about the general kind of objectives, scopes about this
This
working
working
group. Yeah.
Okay, so a lot of crowd working group is kind of one thing is information sharing, the other one is a kind of collaborative build up of some kind of say cloud resources, maybe open wide. So that is kind of a target goal in the beginning. Then so everyone was trying to put some resource, but it's a resource, but these resources are becoming more, yeah, I see, you know. Now everyone talking about GPU clouds thing, which is really expensive. But the talks are also, I'm also learning very much this cloud native style. So supercomputer, actually GPU resource. So the goal is, okay, educate people for how to build up and they're learning their own cloud cluster. That's one thing we have to, yeah, kind of progress. The second one is build up, say, open-wide cloud shared resource to help some group like the disaster mitigations, working group. That is another part of the thing we are kind of trying to, yeah, yeah, put some effort together. That should be the answer for your question.
So to me, cloud and the networks, they are very closely connected. But roughly speaking, from a user's point of view, they represent very different resources. Right? Cloud is mostly computational
Yes.
nowadays, containers, CPU, GPUs, while networks, right? In general, right, we have here this conference about research and educational networks. These are mostly backbone networks
Yes.
for the communications of data. Then for cloud, I guess a lot of networking research are really within the data centers, where you have networks, infrastructures that connects the switches, the routers. And within the data center, you might be able to do a lot of interesting things where maybe things like software-defined networking got a lot of applications within the data center. So yeah, so to me, how these are kind of can be unified and connected when we talk about resources and sharing.
Okay, then so share the resource. Let's start from that keyword. So we want to share resource. Everyone here want to use some of the resources here for their applications or their own development. So then fundamentally they requires three resources, right? Computing, storage, and also networking. Okay, APAN do provide this wide area connectivity style of networking resource, but it's just one thing, right? So the other ones, they do need to rely on cloud style resources. It may be just separate standalone clusters, but the trend, it's better to have this resource kind of pooled together and to be shared, right? That will be more futuristic direction to go, right? So it's better to share that way. And I think our speaker is ready to go. So let me introduce Mark. So he will give the talk about on the study of network architecture visualization and softwareized BGP testbed on update. Please welcome Mark for his talk.
Okay, hello everyone. My name is Mark from National Cheng Kung University, Taiwan. And before my sharing, I want to pass on my Professor Bang Wei's greeting to all of you because he has some personal thing to do, so he cannot be here in person. So let's start our sharing. Okay, my topic is on the study of network architecture virtualization and the softwareized BGP testbed. And this is an update. Okay. So first, the motivation is in recent years, the information and cybersecurity have become more important, as you know. And in the network operation and management domain, especially being important. While this change about apply new regulation, new policies have brought some impacts impacts on the network research and education, and especially for the internet innovation ideas. Maybe you want to do something special, something new, haven't before, something experiment, especially experiment is it's cannot to do. Okay, so here are below are two example in real life case. The first is the zero tolerance for the suspicious events shown on incremental panel. So if your operator the panel alert, you are in trouble. So the second is my personal experience. Last year I host a smoking with Bangwei hosts a smoking in our school, and that is prohibited because it periodically send ICMP packets to some servers, and they against the firewall rule in my school's Palo Alto firewall. So we got in trouble. So that's a problem. So but providing a free, open, and non-blocking infrastructure to support research and education less than an initial machine to the academic network, the machine for RAN. But it seems like we are moving away from the fundamental responsibility here in Taiwan. So we are the end users, and how's the alternative ways? Maybe we can asking for the operators that can you add a bypass rule for me? But if you add a lot of rules on the firewall, you know that will make it difficult to maintain the firewall rules, or you just give your money to the others and switch to the commercial network for conducting like I said, the cybersecurity experiments. But it takes money. So how about we build a self-control network to avoid those potential interference? So it comes up our tunnel-based BGP testbed. So we look at guns, you can find that we have success to connect to the Southeast Asia and connect to the America and the Europe. So the first thing is our overseas routes are all use dry tunnels because now we are no money to buy the private line at this moment. Okay, and the second is the domestic research and education routers are all relies on a torrent VLAN to connect it. So, okay. So our facility are sponsored by NCHC, NSTC, and APAN and 10 and Asia Connect. Okay. So when it comes to IP transit, so you can find that we have three types transit. The brown one is all transit by torrent. So we connect to the rent about like SingRAN or Internet to or YesNet. And the orange one is we buy some payable providers to transit our IP for us. And the green one is for transit for free. Okay. So you can check that. Our network has passed the routing security validations. So, and if you go to a peering DB, you can find that our AS has passed get the MANRS page. So the spoofing test is passed. And when it comes to the network performance status and performance, you can find that on the persona, our network is working. And when it comes to the network flow, you can find the Equorado. When it goes to traffic, you can check that our elastic flow. So above them, maybe some people have know that we build a BGP testbed, and so how we use the BGP testbed. And the next is the first use case. The first project is we build a BGP training playground, and next I will call them the IXP playground. Okay, so the collaboration project aims to build an essential virtual and hybrid SDN-based internet exchange point (IXP) with the internet resource to conduct BGP network experiment. So this project you also provide the training tutorial, IP transit to support students to practice BGP and SDN. So this is an education project. And the project was found in APNIC Foundation and ISIF Asia. And we get the ISIF Asia Awards 2023. It means the last year. So the project investigator is Proofling from the University Malaya, and the co-PI is my professor, Dr. Bang Wei, and the Dr. Eris from SIT Singapore. Okay. So the main idea is we use SDN network to connect all the remote player and maybe some co-location player together, and we do BGP in the SDN network and use some mechanism to make them can transit IP. And the network resource, some of network resource is used by above I said the BGP testbed. Okay, so now we goes on the core mechanism. So how we do the IXP playground. The core mechanism is you can immediately we do like NAT to NAT is do the IP replace from the private to a public. Then you can access the network, right? But we can do like the same mechanism on the BGP world. So AS6501 to AX6503 is the private ASN. So in the beginning, actually it cannot be accessed the outside network. So but use our IXP playground. If you want local transit, we can transit at the AS9267. And if you want to transit to outside, you can use the SDN way. The first is the advertised routes with a private ASN will be filtered at upstream session. And the second is we allocated prefix for players will be aggregated when sending the advertisement to the upstream. So if your ASN is AS6502, you want to do the advertised route to the internet, you will go through the AS9267 and we will replace the ASN number to the 9267, make our AS to do the advertise for you. So the private AS now can access the real internet. So this is the core mechanism. Because of it, so if you cannot just register ASN or buy IP from the APNIC or some NIC, I don't know. So usually you can have your private network and with IPv6, and you can learning how to BGP, and maybe you can training on it. So, but because of the budget, currently we only provide the IPv6 access to BGP player. Hope one day we can do it on IPv4. So the second is my personal experience. 2 years ago, I found the side project called the Cloud Infrared. And why is called Infrared? That's a small ISP built, operated, maintained all by students in my school, National Central University. We provide the cloud environment to students and community for free. And we support projects, we support computer resource to the open source project. So from my point of view, the BGP testbed dramatically lower the barriers to have a pure, free, open network environment, and it's not commercial network. Do you think it sounds similar? It's the initial machine for the RAN, but we comes up some problem. In the past, as above, I say, host smoking is not allowed. So if you are an IT, you are a tool guy, you like to build a lot of tool in your machine, but if you are under RAN, you cannot do something in the network. So for now, we can host smoking, and in the past, we cannot do reverse DNS lookup since we don't have the authority of IP address. And obviously, school cannot change IP for us. But so we come up with this problem, so we ask for my teacher, say, can you help me? And do you have any idea? Say, oh, how about we connect you? How about you connect your ISP to our BGP testbed? So thanks for the torrent, the one of NRAN in Taiwan. So we connect our school to NCHC by VPLS over the VLAN 589. That's a torrent VLAN. So after we access the BGP testbed, what's different? We regain our control of our network. We can decide our own route. And now we have enough IP address to give to users. and the range of technique we can practice just got higher because in our school, only the school computer center have the router, have the gateway to separate IP, and the whole school is under a big LAN. So if in the beginning we only can do the layer 2, but after we have the layer 3, we can practice more. So and furthermore, so after we connect to the NCHC, so now our ISP also can join the ISP playground. So student in our school, we can also practice BGP on the SDN February ISP playground testbed. So what do we do now? In Core Infra Lab, addition to the daily use, like a student may register a VM on our ISP to like practice CI/CD, build their pipeline, or just want to practice Linux. And now there are two big projects are under progress. Is we support our node to train new operators. Most of them are students, so we provide our tutorial, provide the environment, provide tool to them, make them to practice to be a good operator. And the second is now we are cooperating with the FreeBSD Foundation. We support a project that they want to port OpenStack to the FreeBSD. As you know, in previous, OpenStack only can run on the Linux machine. So now FreeBSD Foundation are move forward to make OpenStack can run on FreeBSD. So we support them, we do tests, and we support the infrastructure and then network to the foundation and make them to test. So also shout out to my school and the Teach Learning Development Center and the IT Lab, Bangwei's Lab. Okay, so above is the two use case is in progress, and the next is a future research topic. The topic is for smart and trust routes. That is still in the before kicking off stage, so it's very early. And the research focus on monitor and collect BGP routes from different upstreams to build an automatic recommendation application to adjust the local preference and the ASPX prefix filters for smart route approach. So by adjusting the approach, the property of router, the design and development is expected to use software-wise mechanism because we want to enable more innovation practice to the of SD-WAN to satisfy multiple demands in different scenarios. So, are you okay? Wake up. Okay. So, we will grateful to if you could be our research collaborator or infrastructure sponsor or be an IP transit provider to support this test bed. We will really thank you. So if you want to, we are actively to looking for a new partner to peering with us. So if you are interested in our project, you can just contact the Prooflink or Proofsite or Proof Aries. The mail is on it. So thanks for your attention.
So you mentioned this SDN based IXP playground.
Yes.
Yeah, so this is great. So I noticed that there are researchers on software defined internet exchange point, or called SDX. There are a couple of different proposals. So I'm just wondering, how is your solution different from others? And for the kind of SDN, in particular, what kind of programmable functionalities you are using, whether you're using OpenFlow or programmable even data plane like a P4. Yeah, maybe it's a little bit more detailed. Yeah, but
Okay, I think that's a pretty good question, but unfortunately, I'm a user. I'm not a professor to build this project, so maybe Prof Kim or I found that Bangwei is online, so if he can answer for you in person, that would be nice. Let me check it.
เอาไง Are you hearing us?
Hello, Prof. Kim.
Yeah. Yeah.
Oh, hello, Prof.
Go ahead
Chowdhury,
and
Prof.
answer the
Kim.
question. Yeah.
Hi,
Please.
Bong Wei.
Oh.
Actually, this is Richard.
Professor Richard, nice to see you.
Okay, yeah, I'm Richard Ma from National University of Singapore.
We have communicated with email before lots of times, but I think it's the first time to to see you. I can see you on the screen, but sorry, I didn't bring my camera to the school, so I can provide my video stream. Yeah, nice to meet you. And for your questions, actually, we have deployed the sewing switch in the test-bed infrastructure. As you know, we have a previous collaboration with Dr. Aris on the P4, but we have found that if we would like to collect multiple RIB information and put them into the FPGA or the P4 switch, it will be a lot of cost on the memory exhaustion. So we may need some software routers or software hosts to collect the RIB information, then try to make some try to reduce the route prefix information and put them into the P4 switch. So that makes us feel a little bit difficulty to make the testbed deployment. So for currently, actually, we only use the sonic switch to collect the information. You know that it's basically on the software, right? So we can use actually the lot of memory inside to make the configuration. But yes, we are considering to migrate it to the some advanced P4 switch with the Tofino 2 chips, but due to the budget in our research lab, this might be our future milestone in someday, I think. Currently, most of the things are based on the BERT2 and the FR routing. These two software routers with the powerful server to replace the role of the physical routers.
Thank you. So I'm trying to understand what is the kind of functionality played here by SDN, because FRR routing, all these things can be enabled by traditional networks, right? You have traditional routers, switches, but what kind of functionality, the programmable functionality here, you leverage you use the SDN so that right, traditional technologies might not be able to provide those functionalities easily.
Yeah, that makes the point. You have to translate this information back into the SDN-like protocols. Yeah, for us, we still use the classic OpenFlow 1.3 as our standard. So as you see, the routing information with the next hub address or the MAC address will be aggregated and put them into flow rules with the OpenFlow 1.3 standard.
Oh, I see, I see. So you have now you have a control plane which is logically centralized, so that you can aggregate the users' kind of requests and then deploy distributedly into the switches.
Yes, that's right. But I have to, frankly speaking, for this, actually, we use lots of proxies to make the legacy information back into the SDN ones, or we say the OpenFlow ones. This is the bottleneck in our infrastructure. I'm trying to figure out some other native ways to replace this part, but so far being, I'm still stuck at this stage. So this might be our, one of the future direction to use some original or native SDN devices to replace the current ones.
Thanks.
Okay, any other question? Okay. Now, yeah, thank you. Thank you for the speaker again. Yeah. So let me see how many minutes do we have? Oh, we have about 20 minutes. So probably we have just kind of open floor thing about 20 minutes to discuss things. Anything you want to chat or you want to share your idea or opinion with others, I think we can go with that to spend our 20 remaining minutes. So anyone? Okay, so if nobody's talking, I need to talk, right? Yes. About what should I say? This morning I talked about cloud native supercomputing type of thing, right? And also, several talks are mentioning learning Kubernetes clusters. It's not that hard, right? There are a lot of good references. You just need to follow the steps carefully. But there are several design level issues. Also, you have to experience by yourself because before you really run into production mode, you have to practice. But you should be competent, right? So build something and then maybe something should be broken, right? And you should be able to fix. Then you becoming competent. Okay, I can manage to learn this thing. So that's why there are a lot of talks talking about the keyword playground. That's usually the kind of approach with our open. We went through something called open federation and pain plus, double plus, triple plus. Yeah, we have to gone through those stages and then a lot of playground effort. Then we have become more confident. So I do recommend you guys to do the same thing. Start with a small one, really build some kind of small size infrastructure. Yeah. Okay. That actually reminds, I also have a lot of intern students who is starting with that small cluster for his, it's real one. So then the most hardest thing is configuring the network for that. It's not really following the steps. It's preparing the really environment to let this cluster connect to the network. Like this BGP playground is the most difficult part when you are starting. All this, security rules about the network, they are giving us so much trouble. So things are kind of becoming hidden. So, okay, if you are, I'm kind of old enough to know, the internet things in the early, so I say, end of beginning of 2000, everything was you are using public IP address, and you are checking your route to another one using ping and trace route. It's there, but now everyone is hidden, right? Otherwise, you'll be attacked too much. So everyone hidden behind private addresses, and also this kind of BGP playground. This thing is basically telling us. Otherwise, you cannot play with any L3 thing. You have to do a little brilliance L2 thing only. What I want to say, yes. So the techniques, what to say, those knowledge buildup is there, but the actually playing the game is becoming harder due to security and the privacy reason. So playground, this thing is definitely the way to go. And then once you build and then small production give you some confidence. And because I also been learning some kind of small production, can say cloud. So originally from OpenStack, now cloud native one several years. Then we are doing some kind of internal, let's say, training playground for our graduate students. So also that build up gives us kind of power to design supercomputing style. It's not like it's production one. It's not really fully into that, but gradually moving toward. So this morning also we had some Slum and Kubernetes scheduling. Harmonization of this thing is really the main issue because so you don't want to keep two separate pools. Okay, the question or the problem is high performance computing. Okay, you have resources to be shared. Then now we have a Kubernetes which is more flexible in grouping resources together. Okay, Kubernetes is good in grouping resources together. Kubernetes orchestrator is good for reasonably good for managing, say distribution of workload across all these tools, but they are not really good at, how should I say, large volume and workload. High performance computing ones, they are many nodes, multiple nodes thing, right? So tens of nodes, hundreds of nodes, they are very much into that one. Okay, now think of the workload. Some workload are becoming heavy. So AI workload, for example, LLMs, right? Large scale language models, even though SLLMs, they are pretty big. It's multi-node thing. It's multi-node is actually basically, in some sense, it's MPI-like ones. So your scheduler should be able to kind of go straight all together with a lot of groups at the same time. But also you have to know the flexibility of the Kubernetes together. So this is kind of harmonization. I call it harmonization between HP style scheduler like Slum, RBS, and a lot of songs. And this Kubernetes thing is another one. Also, but if you look into this problem too, you may know also some batch working group of Kubernetes also working on this side. The progress are being made. So what I can say is the Kubernetes kind of the community is also aware of this thing because the workload are becoming larger and larger. They demand more resources, not located in single site, maybe multi-site, federated resource eventually. So this batch and the cluster, multi-node cluster problem. So things are going into that scale, become more so complicated and kind of scale out and up. So anyway, that thing is giving us a lot of challenges, but at the same time, it's giving ultimately years later, solutions will be ready. You don't need to worry about separating. This is for HPCC, this for container, no, Kubernetes-based container. You may be able to make them in single pool. Just your schedulers are aware of, those characteristics can meet some workload demand as for HP style can match this way, and then more this GPU heavy and a lot of different, So they are not there. A lot of discussion going on how to make that happen, and I also in trouble because my resources is divided into separate resource pool. A part, B part, they are separate. So I can leverage, say, resource sharing, but some resources are remaining here. But this is poor, but I cannot move it. Kind of client from this side to that one because this, so partitioning is there, right? Anyway, so you guys will know this thing will improve. The another headache is this security thing, The namespace in the Kubernetes giving us a lot of, say, techniques to isolate users, a lot of different namespaces, right? So then, but automation related ones, also the data level, that's a different one. So what I can say, with Kubernetes, you can leverage so a lot of namespace techniques to isolate because this user and the then user can be separated. They are kind of putting some kind of, say, hidden word, but it's not really fixed word. It's hidden covered word, like it's the fabric style words I put there. So it's very much flexible and it's working, but it is not really giving us hackers going through that, right? They will just put holes in the fabric, right? They can test. But anyway, the different level of kind of protection can be arranged along this. A lot of things, what I'm talking about is you may know about something called virtual machine. Okay, virtual machines still you need to use that because of this security reason or some maintenance reason. But a lot of places when you want to maximize your sharing efficiency, virtual machines they are too rigid, right? Because this room, the problem when we have this room full, you want to share some part of the room next, which is kind of only partially occupied. It's impossible, right? The partitions, sliding partitions are good way, but isolation not there, the noise is coming between the rooms. So this is the problem we are facing. So But definitely some progress will be made on this side as well. Much flexible partitioning things so will give us way to go forward. So a lot of problems, I also been looking at this problem for several years. A lot of progress has made, still a lot of things to be solved because of new demands are coming. And the cloud is actually kind of matured and ready to use because we are using for our graduate school and the development center, and a lot of other people are saying we are not using any commercial software at all for this side. So our supercomputers is not running. Okay, we have some licensed one for automated installation and configuration. Besides that, no, commercialized say code software is there. That's a good thing, right? Okay, I think I kind of spend some time to chat about those. Now my chat will give you some things to talk, right? So how many minutes? Yeah, I think I spent 10. So now we have 10 more minutes. Maybe anyone? Yeah.
I'm just curious because the previous talk mentioned about OpenStack. So I'm just curious if the audience know the status of OpenStack, because this is came from maybe 5 to 8 years ago when I looked into the cloud domain. So I previously worked on open source distributed streaming systems like Storm, Flink, those kind of thing. But gradually, I noticed that the cloud resource orchestration will become very important. So at that time, I was looking into the state of the art alternatives. So at that time, I saw like Mesos, Yarn, OpenStack. Also, I started to see Kubernetes. So at that time, Yarn was probably the most important one. We take a look. At that time, from a design point of view, I thought OpenStack was probably the most promising one because it has considered not only the computing storage, but also the networking parts and different components. I guess I didn't really understand Kubernetes at that time. But after like 4 or 5 years later, look back, wow, the other animals kind of died and then everybody jumped into Kubernetes. But I'm happy to see still OpenStack is there. So I'm just curious, what's its role and how do you see it might evolve
OpenStack
into
is still there out there. It's living. Yeah. Even in my supercomputer, we do have OpenStack part for kind of operation servers.
But definitely it's not playing the orchestration role as Kubernetes today, right? But it used to claim that it will become like but now the role becomes smaller, I guess.
So yes, this comment is giving me, okay, I was also heavily involved in OpenStack, not really involved. My students, yeah, they do. We participate a lot of OpenStack events for many years, from 2012 to 3 4 years. I just regularly attended them, and but they was really going, growing, but suddenly they start because they have to build so many things from the neutron, let's say SDN adoption, and so many things. Over the main problem is it has built from the bottom to up so many things. So they were successful in the lower bottom part, but when they are going up, they do have problems because they was not really thinking of the applications. They was busy building the basic building blocks, and then they could not cover the demand. So okay, so also I still remember the big tent, failure thing. They tried to cover everything under the slogan of big tent. Now we have every working proposal just come in and so propose your things under the big tent. It cause a lot of chaos. So you don't know which one to follow. There's so many things that I can do this, everyone is dreaming, and then no really working code. It creates a lot of, let's just say, ageism or something. Yeah. Anyway, I remember then, so a lot of production thing, it worked. Then after upgrade, it's not working. So many trouble. We also had a lot of, so because we were regularly updating our, say, OpenStack from Havana to something I cannot even remember those names now. Yeah. So things, but after those struggle, I jumped to this Kubernetes thing for about 6 or 7 years ago. Then things are becoming much easier in this side, much more simplified. The layer of abstraction is much clearer because, yeah, Kubernetes orchestration there in the middle, right? Everything is kind of isolated up and down. So that simplicity is giving us two scale, and so that's the view. So also, I also remember the Yan, Mesos. I also did several studies and several deployment trial, which was not easy, right? I also tried the Mesos with some kind of other Scatulum and Mesos, that kind of thing. So everyone tried the different, yeah, combination of, yeah, tools. Okay. But then that said, options still there for a lot of people in both cloud people. Option state plays a lot of work. But the main problem is it's good for kind of giving us to divide the URL into small pieces and then asking them to pay and then giving. For that purpose, it's still perfect because you don't need to worry about it. You don't care once your kind of, say, tenant is paying you and giving you money, then something inside is theirs, right? Then you just need to care about the security outside of those. So that's perfect for that purpose. But now we are talking about new flexible type of workload, right? You want to utilize your resource as much as possible. Some resource isolated and dedicated to that specific room, you cannot take it out. But that's a real problem because it's for paid service. Cloud is good enough for your internal ones. Your kind of, say, if you belong to one company, the other divisions, they don't want to pay you. They just want to do their part. They just claim a lot. I need this much, but they will not use. You know the kind of, say, situation, right? Everyone wants more piece because they should be ready for their big demand, right? Peak. So the resource cannot be properly utilized. So its scheduling itself is really trouble, right? So, but Kubernetes, it doesn't need to pace that thing, right? Once everyone is really ready, they will start using the resource. As you, for the CPU side, it's pretty easy to make that happen. For the GPU side, still it's not that easy to make that happen because of the GPU needs to say, affinity thing. Okay, so now the GPU jobs need multiple GPUs together, but it's like this, okay, you should sit together in one table, GPU. Then the memory of GPU can be used all together for your inference job. That is the different concern. For the CPU, you don't care where you are sitting, your CPU is located. So that is giving you a different problem phase. Anyway, this resource efficiency game, so those, say, cloud and the cloud native ones have a different, yeah, ones, but they do have their own nodes. They're unique and dedicated. For their specific purpose, still you have to solve, which I call it, I like the word harmonization, which personally I call the PVC harmonization. P actually means physical, V means virtualized, C means containerized. These three things, you should select the best mode for your workload and also depending on your situation. But this is pretty much interesting thing, and you should be able to manage all these three kind of, but containerized ones are becoming more important. Yeah, less virtualized is the way to save your headache because if you want to calculate 3 different things, it's pretty hard to manage. You want to reduce one thing, 2 main thing, and 1 minor thing, right? That's much easier game to play. Okay, anyone who want to add the last word or we are already 2 minutes to go, so I think it's ready to close, right? Yeah. Okay, then thank you for joining us. So actually, it's my comeback on-site one after COVID. It's been I regularly attending the JPAN, mostly on-site, but I came back after 4 years. But I was attending this one also. But it's really good to see people face to face and then talk. Then hopefully this cloud working group is thinking of making this thing more now it's becoming more matured. Also data is really becoming the core part. How to allow sharing of data, because cloud working group, why you are using it? This cloud is have some big computing resource as a storage resource, so you want to put your data near to this cloud, right? That's natural logic. So, but people don't know how to really put the data together. Okay, conceptually, bring data together is very much easy thing. But if you really want to put your data together, it's really become complicated. Think of your warehouses. Where are you putting your data? How can you find out your data located some of those shelves? Everyone has your own, so to say, warehouse or some kind of, garbage space. Then it's pretty hard to find out here the data is also making them safely isolated. That's another problem, right? So cloud working group definitely have to spend more effort. So the data shared, then using cloud resource, then for our AI support. That's logic because I belong to AI Grad School and Supercomputing Center. This is the role I'm playing, and a lot of you may also have to play the similar ones. So please, please put more interest in the cloud working group, and so give us idea and also propose your talk. So we are open for that discussion. And thank you for attending. And thank you. Let's finish.